today is my appointment with the analyze. Yeah, you have it also in your head forward. Next Tuesday, the lecture of my colleague. So please be present. That lecture so that nobody will just always probably questions or something. Already so please do not rest that way. Okay, and what we will do today, we will continue technologies that have been useful for many and other we have done what quite today you will do. It is not so there are a lot of like machine learning, deep learning, perhaps agentic AI, and a lot of language models, etc. So we will not do this today, but what I do is to implement in general when we look at that we need some and when we should I think that we would by the way, noise nice and here. This is in the room. I don't know. In the room. Every time I log so the room is okay, WebEx it's not. I don't know. Great. Now let's go to artificial intelligence. First, any thought about it? Suggestion or application? Have you been are in contact with who is not using ChatGPT? Yeah, by the way, ChatGPT is useful and powerful. We have to know how can mislead you over. And believe me, in order to get the potential of the ChatGPT, we should be able to provide good prompts. And providing good prompts for your expertise, you should be expert. Because you can then provide the direction that ChatGPT will look at, and also you are able to check whether what you are getting makes sense or not. Because I see as non-responsible use of ChatGPT when I see words like that, and I'm asking and do not get it. It means that it's really without any thinking. So, by the way, it may seem as a revolution, it is for that. But we had as Google was invented, and then there was this bar, and then you can provide some keywords, and you get more or less connected to figures, right? So it's the same thing. I do everything. But yeah, we have to be very careful. And also, at a certain level, it's in order to use it, it's possible to use it also intelligently. So this is also all large language models, right? And ChatGPT is Yes. Have you been in contact with artificial intelligence? Not so much. I would like just to start, yeah, to go perhaps sometime in the past. Yes, and then we actually review this because of her. What can the computer do relation frameworks? You cannot deal with numbers the way we deal with them. And we use them. Binary numbers. But it happens that the computer. And this is actually economic view of computing, right? So, now, you can see that this is being calculators. Today, some tables but then calculations needed by devices like computers and also computers. Okay, I have a question for you. When something goes down in terms of cost, what happens? Yeah, goes up. Lower the cost, something, the more we use it, the lower the cost of computing, of arithmetic, the more we use it. Right. And it happens also that we may translate some problems that used one arithmetic problems to arithmetic problems. One of these examples is photography. Photography used to be not arithmetic problem. It was a chemistry problem. You're too young, perhaps you don't experience that. Perhaps I don't know. So, long time ago, actually, in order to get your photo, well, you had to get the photos on. So, not was not really simple. Now, if it's it's like a piece of music, digital, MP3, or MP4, whatever. It's actually also photos that are so accounting is osmosis. So accounting used to be as now it is digital problem. These were in the past were not digital. Still there are games that are not digital. More and more games are digital. Mails. We had regular mails. Just the letter that you get in your physical mail. These are not and certain format. So you see, something good. We tend to use more of it. And we also tend to transfer or to translate some problems that used to be non-arithmetic, non-arithmetic or calculation. You can call it. You see? Why? In order to grow. You an engineer could very perhaps will tell you that it's neural network. It may look like it. And speak to that neural network. Here we have a cow. And then ask the neural network whether we have a cow on the photo. So a trained neural network will tell you, okay, there is how the photo is spread. And here, by the way, I would like to draw your attention to two types of understanding of a picture. So, at least, let's start with engineering perspective. The engineering perspective is we understand artificial intelligence is a neural network. That is artificial intelligence. Now, from an economics perspective, what is AI? AI is about actually the reduction of prediction cost. By the way, I'm right because I asked this question 3 times by former exam. When the engineer and the so please, if I answer this question, I would like to. This is very important. So to have 2 different perspectives about how to define artificial intelligence. So the same thing that we have with respect to arithmetic and computing, artificial intelligence is doing anything else lowering. It's actually at the end, and it has many times. Yes. And we'll see many examples how AI actually at the end is a matter of prediction. Right? And this is the thing. Shooting that the cost of arithmetic down, we try to translate many problems, not an arithmetic problem, to an arithmetic problem. Now, since the costs of prediction or cost, let's say, we tend to translate that used to be not a prediction problem to a prediction problem. We'll see some examples. This is very important. AI is doing nothing. By the way, a time ago, I have written a paper, a scientific, because authors don't define AI very well. In general, by the way, you may find a lot of papers speaking about digitalization and AI. We have to be very careful. AI is not equal to digitalization. IoT is not AI. IoT is perhaps it may use AI, but IoT is something different. Internet of Things is not AI. Or blockchain is not AI. So we have to be very clear. AI is that when we somehow some predictions that for regression analysis as a tool for AI. So it should not be always neural network learning or whatever. So whenever we have a prediction, we can talk about it as artificial intelligence. So what is prediction? So we should define it. Prediction is easy to define because using information we do have, information that we do have, in order to generate information that we do have. Right? This is a very simple definition of prediction. Now, what we are doing now is the range. So we have like driving to an AI problem, to a prediction problem. Why? A prediction problem. Driving is, what does it predict? Yes. They think that they either have some people, some drivers, highway that are unpredictable. You have to be very careful, still, and manage the situation. Actually, autonomous driving is about what a good human will do. So autonomous driving is about predicting the behavior. So here, no, to have an autonomous car, we should actually a lot of data about the good driver. Certain drivers reacted in specific situations. And this is, by the way, the good thing about AI. So, when using algorithms, there are sequences of instruction, and it has been tried actually in the past to use algorithms for instructions in order to program so that through the highway or through driving in the city, etc. It happens that there is situations we may miss because we are programming or we are inserting instruction by instruction, right? And if we miss, so instruction means if then rules, if then rules. If you have the situation, you should react this way. If you have the situation, you have to react this way. But with we should not. With AI, we should capture behavior of human in situations that are perhaps difficult in normal situations, feed them into the AI, and then move it train the network in a way that it can react well when trained certain driving situations, traffic situations. So this is why AI is powerful. AI is powerful because we do not need to program these if-then rules, inputting data, where based on that data, the AI will be trained. Yeah, this is also, this leads to something which is perhaps the difference between a substitute. So we have seen that the cost of prediction will go down, and we have to uh, what we call substitute. With regard to substitutes, how people, yeah, I'll come back to it. I need just to give a. What about copy and paste? I know many people that are teachers and people that are teachers. And there are people, there are many people. What about these people? What's that? People have a lot of trainers that have been drinking tea, jumping again, or going to copy one because who is doing that? Tea and so coffee goes down, there's some tea drinkers. Drink sometime. They will switch to coffee. I don't really believe. Now, what about consumption of coffee? Because started and we have so what about the business class? For example, sugar and cream. Sugar. The cost will go up. So the cost of production goes down, more of it, like the cost of coffee goes down, drink more. But what is the company that we have to exactly stay? So here, sugar and cream for us will be because here cannot explain our and therefore data will increase. I'm looking for more and more training data. So here we have a bunch of examples showing how certain programs have been actually translated to AI problems. Finally, we have talked about translation. Translation with current, which is amazing, right? Do you agree? It's just amazing. Yeah, perhaps it's not using the neural networks. These are large language models. Yeah, they are doing a lot of good stuff. Protein. For example, seeing anomalies, let's say, in certain could be also a sign for a certain fraud. And this is what actually AI is really good. In this situation, you have somebody making one single purchasing or some purchase, some purchasing at 5 different days, Monday to Friday, making this purchasing from Italy, France, Germany. Norway, with Austria. AI may actually anomaly in the behavior. May this person is 5 different days, transactions in different. But for example, if AI knows that that person is so working for an airline, I will show no. But if it is not a problem, if it is not a yeah, job is not related to faith, and perhaps it does not mean that there is some fraud there, but car loans. Yeah, loans in general. So when you go in order to get from a bank, yeah, you are actually giving to the bank all of not for the bank. Then at the end, tell you your loan, your credit, right? So they will be checking. They will be previous bank transactions, which extent your loan flows, like I mean here. So, yeah, this is what bank is doing generally. That one talking about whether the loan will be given or not. But now it is actually done easily. We are not talking about neural networks, we are talking about. So, yeah, you have different, you start with, is, I'm just giving it. It's older. Verify salary here and 50,000. 50,000. And what about last year? Back. So we are going this decision. Natural and whether to give the loan to the client or not. You construct based on the data analysis of big database lines of the bank in order to extrapolate the similarities and categories. It will give us a prediction. So with 80% prediction, that client would be paying. Okay, some banks would say percent is a good number, is a good threshold. Which is perhaps the threshold is 70%. We give to the client the loan. If it is lower than the threshold, it's just 40%, and the threshold is 30%. Denied and not. Then we have the email replies, also automated. HR also is a very nice application. Artificial intelligence sometimes we have to think about ethical aspects because, yeah, at the end, what there's a neural network in the past as of the people that have been employed and the people that have in the end, the neural network will just mimic. And if there is that some people have been excluded for whatever reason that is logical, then the neural network. And this is, by the way, and then we have inspection. Inspections, and we would often use a very specific example. Inspections where the artificial intelligence can think whether there is a defect that can help you actually in making maintenance, inspections, etc. Also in the medical sector. In the medical sector, AI has a lot of applications. Well, yeah, you can show the tissue of the brain, the tissue of the body to the artificial intelligence, and the artificial intelligence can decide whether it's tumor or not. Exactly what actually comparing a lot of pictures that have been fed into the system from different patients, and then you get some prediction is probably how is that the tissues contain a tumor. By the way, the doctors and the system have to think about their job. Because when you go to your job, nice on two things. Yeah, two things. What is the training data? What is the training data? Of course. So, what is the experience? Is the number of situations in which has been managing or has been encountering in the past. There is also, before the experience, there is something which is important. The knowledge, which is formal training, studies, the formal training. So there are two things: the formal training at the university and the experience. Now think about that you can feed into an AI all the papers of medicine that have been written since publications started to be made, right? So the AI will be trained based on the basis of a small portion of the information, but based on the information that is existing, right? Yeah. So we are now is two to three doctors have a different opinions. This is good, right? This is okay. We are not at that stage, but let's try to make an experiment. We are training the AI based on a lot of things. So, by the way, do not get wrong. I do not think that I do not think so. AI, what any technology has, replace certain jobs. There will be elements that you will create sure new jobs for human beings. This is important. So the things that stay, if we look 70, 80 years ago, 100 years ago, is that the job computer developer or digital designer? Hasn't been these jobs. But these jobs exist now and they are very known. Right? And who knows, in 30, 40 years, what are the jobs? Believe me that supply chain management will be needed all the time because this is very important. The only thing is that the job of the supply chain manager, and this is good. Yeah, very nice example for inventory management is this one, which is computer vision. So you can have robots, for example, going through the shelves in a store and seeing where this and then communicating with the human operators to restore. Yeah, perhaps you had that. It is like to get your preferred product and it is. of the day. And there's because I decide as a client not to apply. I switch actually to another product or competitor product you have. And perhaps you have, and the manufacturer will sell a product also. So for inventory management, you use computer vision in order to, yeah, to do teachable machine by teachable machine by so we will do an experiment. A very simple one. Yeah, you see the link on Google. So we will go there. You don't need to go there, just okay, I'll just stop sharing for a second. And we will go to teachable machine. Machine with Google. And then what I will do is I will train, I'll create a very small the neural net. I will effective smartphone. And be smart. Then train the algorithm. Then we will test it. We will give the neural network some pictures. The next, whether the smartphone is detectable. So I will not do it with the big data, with a lot of data. I'll just do it with small. I had to look for some pictures for defective smartphones. And the internet I have done it. But you can do it for more. And by the way, you can also use the in order to detect whether you use defective or not. So we will get started. So we will have an image project, one image model, and then you have this. You have here. I can create more classes. Yeah, with two classes, it's fine. You can create even more. See, you have here a webcam. Show the camera, show the pictures or the devices, camera of the computer, and my room. I will upload uh, uh, to show. I will stop sharing for a second. To share the screen instead of the computer screen. And all the steps. Okay. Sure. I have some pictures. I will be. So you can see here some pictures of defective phones. I don't know whether you can see it. So, but all of them, it's on the screen as defective. It's broken, it's full. So, okay. I have. So I will call this class defective. Then what I will do, when I and then I will upload just to show you perhaps the pictures because before. Example of the picture. Okay, let's upload. So pictures, not so these are smartphones. So this is training. Not saying. Yes. And it's not ask the to categorize whether or not. It will give us a proof. Each order to present is effective or not. I will, I will show you the picture before we go. So this is the test. So this is the first one. What do you think about this one? Normally the computer should translate it. The second one, and obviously it shows one is new. No problems with it. I have another one. So it is cracked, but still functions. You still have everything, but it is cracked. And you will see what the algorithm will do. Yeah, of course, based on this small number of data or of data points that have been. Okay, now let's go again to the webcam. Of course, I can show my phone on my computer. You can do it as an exercise at home. So I will data from the phone. So I will show the cracked. Show the cracked. And if it is defective, so the computer detected that phone that is defective at 100%. Okay, I will show now to the new phone, and then ask the computer whether it is defective or not. And then you think non-defective, 100%. Now, what do you think? They show the computer the one that is like still function. What will the computer do? It's an experiment. It depends on data that we investigate to the computer. So this is the cracked form. Cracked is not different. 100%. Okay. So you can first, to make it more sophisticated, and get a bigger data feed it to the system at the end and have much better, I would say, application than the one I have now, a better project, because it is really based on a couple of pictures and not extensive. So you can use it to make some project that you think is really very practical. Let's go back to the slides. Now, let's think about how to design and automate processes. So in general, when we think about AI, we have the idea that AI will completely certain processes. So let's say it is an end-to-end automation, which goes far away from that. End-to-end automation. The automation processes still far away from that. In general, we have a workflow. So this is the entire process. And in the workflow, we have certain tasks. Right? Specific tasks that we have to do. A task perhaps to look at whether we reach the replenishment level, the ordering level in our. This is one task. So no good the entire process of entry, but one of the tasks is just to check whether we are at the order. And then we have to do different decisions with respect to this. Let's say replenish or do not. Place an order with the customer or not. And the jobs, by the way, the jobs, they are a collection of decisions. So when you are working as a supply chain manager or a supply chain planner, you will have to do a certain set of decisions. So it is not only one single decision that you have to do all the time, but you have to do types of decisions, and the job is actually a collection. Now, automation is actually at the level of we have to start in terms of big process. So this is very difficult. But when we automate many tasks and we integrate this automation, we may get at some point in time a workflow that is automated. But we are at the moment away from that. Good. So tasks is what we're focusing on. So, using AI, the automation or the support of a certain task. We should forget about the entire process. Now, we have here autonomy, anatomy of the task. This is how the task looks like. For example, what the doctor does is perhaps based on a certain case, a patient, a certain diagnostic, the doctor will prescribe medicine or some therapy. And generally, when we are looking at tasks, we have to start from this training. Start with the training. Has two types of. The first is on formal studies, and the second is training. You have the training. And then have an input. Let's continue with this because it's very easy to read. So we have an input. What is the input for a doctor? What is the input? Input is the patient. The problems of the patient. The symptoms, the input is from at least two ways, two approaches. The first is by just qualitative, through conversation. And therefore, doctor relies a lot on what you say. So all what you describe will be taken very, very seriously from the doctor, but also what you see. Perhaps using also some MRI, some devices in order to get some pictures, devices that will provide also input. Now, based on the training and the input, what will the will do? Literally, some more probable, more likely. Let's say, I'll give you an example. Yes. Oh, yeah, very, very good. Stage of rest, or it can be a flu, or it could be corona. Flu and corona. The problem is that symptoms will be very, very similar. They are very similar. So, based on the training and the doctor will be making a prediction. And it could be this and this or this. That could be a flu or cold or corona, and then we'll make a judgment. It's more probable. Actually, you will get a treatment, let's say for 5 days. If it gets better, you can stay at home, you will not necessarily get better. Please come back. Because it would be more fair to say, medicine. Yeah, this is the outcome. Perhaps the patient is again healthy, stay at home and will not contact the doctor. Once again, perhaps if you are very kind, you can call the doctor. Thank you for everything is fine. And if not, you would be back to the doctor. This is the feedback and will update, of course, specific things that the patient has spoken about. It can be updated and serve prediction and judgment. I think that you know. Perhaps you haven't thought about how to make it so explicit like this. And it happens that AI works like this. It works like this. And based on that, create the canvas. It is called the AI canvas, artificial intelligence canvas. So here, we start with the training. And this is what you have to ask yourself. When you would like to create an AI for the automated tasks, first of it, what data do we need to train the computer? Of course, we have a task. let's say, need some data. It could be also forecasting task. What data do we need? Well, then we should specify what is the kind of data do we need to run. And what do we need to know which is the condition? Judgment, how do you evaluate for the doctor? She will say only 10% probability that 20% is a Q, or will go for a moderate therapy. Okay, there will not be a big issue, of course. Not of course, but then, according to the doctor, let's say, if after 5 days the therapy has changed since the so these are the kind of judgment. What is the penalty if we make an error? Actually, not too big. Perhaps, yeah, we may go for a smaller therapy, the lighter therapy, and then we can make it more intense. And then we function. This is the medicine. Is prescribed. On the what are your metrics for task success? For example, patient is healthy, and we have the feedback. These are the metrics for your task success. We have the feedback, the outcomes, they are good. We will do it with a more sophisticated problem, and then with very chain-oriented. Example. Now here, this example, by the way, is based on the fact that I told you because you know why? Because every time I hope the experience. I hope it. I should not function. Still, one was in the train, never lost. Anyway, so it really comes from my from a concern. Perhaps I need in order to help me with this to reduce the cost that I'm paying for employees. So what is the training data? The weather-related data. So temperature, pressure, data. So this is the training for the AI. Is weather data. Right? The prediction probability of raining today is 50%. By the way, it may seem very, very evident. I never understood probability of raining. It is the way we just giving you, conveying to you this without any assessment. I tell you, I don't literally understand what does it mean. Say 50% or 40%. 40%. Are we comparing look today with the end of May? 100 years. And yeah, we have seen look when it rains and when it doesn't. We can come up. There are 10% or 25% in the last 1 year since we started in measurement. So and on the website. But for sure, 10%, understand that there is high probability. If it is 20%, there is high. We do not understand. But I put it like this because this is the way. Judgment. And this is a very important judgment. Carrying an umbrella with you, and be sure to not. This is not carrying. And getting what it's like. You see, this is. Who would carry an umbrella if you know that the probability of training, even though you do not understand it very well, 50%. Carry an umbrella with him or with her. Okay, you will carry an umbrella? Never carry an umbrella with her. You should be 95%. I'm sure that it trains. Who will be carrying then with, will not carry with 3%? Will not carry. I'm definitely one. So, then action would be your decisions. But it's coming many times. It's trained, and the feedback, the information could send back then to this training that we should update the model since at good when we have state of brain and actually so this is okay. So this is, I think you have an intuitive understanding of this AI canvas. We would like to apply it for cognitive maintenance. We have here an example with a deep learning-enabled camera application on the mobile device. The network can photograph the machinery that works, and it is similar to but and on a large data set. This is EBM watch. We'll use an AI image recognition algorithm to determine the cause of this is an explanation from Watson about how to fix it. But let's imagine how we have a canvas. And then what will be the training? Training data will be like we did for the example of smartphones. We will feed into a lot of pictures, different situations, or very different situations. The first system I mean is the output, the AI. We are instances of different and the fact that and also we are showing the type, or we are putting in the data set what type of. So this is the training data. Now we have current pictures taken by the plant worker. We know that who would like to know how to deal with that kind of rapid information. Prepare the data in order to get them. Now we have to do some prediction, and this is I'm here by the way, show the example of cognitive methods for the job here is applying with what this is okay, they're applying it. Here we should think about the AI and we are creating the canvas in order to have first work toward the AI. This is what also starting doing the AI, starting etc., which is the most exciting part for engineering. We have to know about our phones. We have to know about it. And then, what is the prediction loop? So, prediction will be the probability of what could happen on the 80% of the code is perceived. This could be one of the or probability could be 70%. Judgment, what we have to do is either providing a solution, plant worker, so Based on this 80% prediction, this problem integrated limit, we have two approaches, or we have two solutions that we can go for. The first one is that we are just saying, provide this. Yeah. Very good. So this is so we are for the equipment. And then we have a client who is the user of this company. And the manufacturer, of course, would like services to the client if there is some the equipment at the and the client will get support from the manufacturer. So this is important. This is we are doing it from the manufacturer's side. Manufacturer having some pictures from the workers here, showing there is a defect, or showing that the machine is not working, and there are pictures. The AI of the manufacturer is simulating the condition and thing. Now, the manufacturer has two options to provide some instructions in order to repeat, for example, this. Who will send you an integrated? In 2 days, it will be written. And then the instructions how to put it or how to insert it in the word. Or they say, okay, we don't do this. What we will do is that we will send, we will be with you 4 days. And you will make. Obviously, sending somebody, a technician, for 3 or 4 days will be much more costly than just sending instructions in order to the machine, right? So this is very important. The thing is, you can create a ticket and then provide the instruction. A webcam or whatever, it's functioning. It's very okay. The client is happy, it's a lot of money, it's service. But if it's somebody that is going to take real one as a client to observe that this work could have been done as well as the client by sending it to register, which this is about this is a lost opportunity that the company could manage to. Now, the action is client work is guided through the regulations. They went this costly. The outcome is just functioning again. The feedback is this will feed the training. When we have a kind of issue, like on the picture, we know 100% that. And then, so we do the same thing. We use by a regular name and the new. Does it make sense? If you get a question in the exam of English, will you manage it well? Great. Now, good. Now, career methodology on which tasks are most good. Some people think that AI is they say, at least we have to do. First of all, we have to break workflow. We should know our then fill out the AI canvas for each task. So you can have a workshop, filling it out, 20 AI tasks, and for tasks that be used for AI. And then benefit of enhancement, generating value prediction. If I know that I implement that, what are the kind of benefits I will get, and especially how costly is the data in order to feed that. So this is very important. What kind of data I need. It's costly. And estimate the error building or buying AI for each task. So we have the benefit. And we have the cost. Estimate the ROI for building each task. And then run over the teams of ROI. Say, when you ROI, you might not implement all of them, you might unfortunately. So type ROI. Those ROI will ROI that is smaller than 1, you will not. This is should break even. Smaller than 1. And this will give you how to select most appropriate things to be used. Now I would like to show that before we any questions? I would like to with respect to very interesting example. You know there by the way, electricity and AI. What does it?
We got.
You can. What is a recommended system? A recommended system. It is a or look that you are have tool also this and this tool. Don't. What does it mean? It means that making recommendations are that you can buy so that you have made given purchase. Given purchase. You bought this. Perhaps it will give you suggestion for a mouse, suggestion for I don't know, for a headphone, whatever. So customers that bought this have bought these other products. You find it at Amazon by have you used this? Books? But it's more or less bias. So, and then the algorithm assumes that there are some similarities. People who are interested in certain type of books, they will be also, they will have similar preferences. I would like to ask you, are systems of Amazon. The precision. The precision is the which the product is your it's high precision, high accuracy. I can tell you, by the way, it's about 1 to 20. It's about, so out of 20, this is the precision, 20 products that are recommended, one is very that people will buy. It's about 1 to 20. Amazon has done this. Recommenders obviously are making predictions. And making predictions about now, let's make this thought experiment. Imagine that Amazon more and more data improve the prediction accuracy of its recommended 1 to 20 from 1 out of 20. Because nothing is so intelligent, knows something next. This how it will go. This will be the next step. Now, now, let's go back one step and then think about the business at high level. The business model of Amazon is actually like this. It could be used really at high level to do types of activities, which are shipping. So it's what Amazon is doing. People are shopping. And then once Amazon is right? But I think the accuracy of the business model, the one out of is amazing. Because we know that there's millions of products to sort a persistent they are just reducing the sort to only out of which you can pick one that is very interesting for you. This is it. Now, one out of if we can reach Amazon can change the business. And this could be destructive, by the way. The business model is completely different. So, we can get a business model where we set the activities to shipping, does it mean literally this? It means you are somebody reads on your door. This is a package from Amazon. A recommender system that we will not tell you. The medicine has predicted in certain you got the shipment, After shopping, you retain some. There would be a reversal bit. This model will imply less successfully the reverse justice will get. In order to take the product, you see how AI and very important. When you think about AI, how AI can change business models. Yeah, there are a lot of and there are a lot of journalism change business models. AI, if it is about inventory management, using it for forecasting, how would AI change the business? How would it change it? Here, this is an example that shows how AI can business models from shopping and shipping to shipping and shopping to what we have been used to. I think, yeah, the professor is, yeah. No, it is not. 2013, already 2013, and you can go to the patent office, the US patent office. You will find a patent by Amazon. It is called anticipatory shipping, where this idea is already patented by Amazon. There are not stories here. Now, I would say, not like this. He implemented that. There's not this one lower scaled down version. It is the same idea. So goods delivered to customers have even ordered them or they need them. So this is shipping and shopping. Of course, we need browsing behavior, purchases history, as well as unrelated data sources such as weather data, social media, etc. But here, what is Amazon actually doing is that effective prediction of demand, shorter delivery time by moving inventory closer to customer locations. That predict what you need. And the UI, what they do is that they put the product to the warehouse. So once you order it, you ship to that warehouse. It is not the full version, so it's a scaled down version, but what they are doing. And obviously, this is because you do not get the packet. So, very it could be examined. Ask about business. So, whatever, actually, of course, we can use it. It's not changing business models. This is AI use that changes business. But any question? More point where any question? Yeah, if not, let's go. Agree? Yeah, we have 9. We continue at we continue. Okay, now we will continue with technology. By the way, most of my students I don't know what is the voting here for this technology inside this classroom, but blockchain. Yeah, and my students like it. I don't know who likes it here, who find it really impressive. Blockchain technology. Yeah, it was like 2 years ago. Yeah, when my students approached me for thesis, do you have? They asked me, do you have a topic with blockchain? Okay. I don't know. They find blockchain very interesting. Okay, perhaps it does not seem to be the case anymore. Yeah, things they get hype and then they are not interesting anymore. But yeah, still, I think that it is an interesting technology, and yeah, it is worth also studying or dedicating a bit of time to it. And good. So this is a technology that could have some impact on the supply chain. The first thing is that, let's start with a definition. What is a blockchain? What is a blockchain? Okay, so there is obviously the definition here on the slide. It's permanent digital record or a ledger, right, of transactions that is stored across a distributed or decentralized network of computers. So you have ledger that is distributed, so that is replicated on many computers. Yeah, ledgers of transactions, ledgers of ownership. Yeah, ledgers are something that we have been using for a long time because how could you prove the ownership of somebody for something? Let's say, how could we prove the ownership of real estate? So there should be a book, a ledger, an authority writing down that somebody is owning a certain, let's say real estate, right? So it's not true, but it's kind of a database, kind of where we store information, right? The blocks that are chained together are cryptographically sealed records of transactions. I think this is an important property of blockchains, that is immutability. So it is not easy to change what we have inside the blockchain. And computers supporting the blockchain confirm, verify, and record the transactions independently. So I think this is a very important also feature that we have a process of authentication inside the blockchain. Good. And I would like here to provide you, okay, first of all, we have to distinguish between two types of blockchains, right? So there are two types. And I think very important for us as supply chain innovation explorers, that we should distinguish between permissionless blockchains, I'm abbreviating with BC, and permission blockchain. So permissionless, it means that individuals, companies, whoever who would like to be part of the blockchain here in permissionless can be part of the blockchain. In permission blockchain, perhaps only a specific set of actors, a specific set of companies, a specific set of individuals that are allowed to participate in the blockchain. Okay, so this is the first difference. And in the permission blockchain, usually, in most of the cases, the participants are organizations. So like the supply chain. So in supply chain networks, you have perhaps a permission blockchain. So it is not accessible to everyone. It is only accessible to those that are part of it, that are, we will see a couple of examples for permission blockchains. Now, I would like to explain blockchain from a conceptual point of view, not go into the details of it, how it works technically, but I would give you a conceptual understanding of how blockchain works without getting in the technicalities, right? And I think this is very important for us. I will try to do it by means of three things. The three things they are represented here also. The first is the so-called hashing. The second aspect that we will deal with is cryptography. Yeah, it's a very, very broad and big area in computer science, but we will look at the so-called private and public keys. And three is the so-called proof of work, which is the consensus mechanism inside the blockchain. This is a consensus mechanism, right? So, hashing, it is about, let's say it is about security. Private and public keys is about trust. And here, it is about consensus. So these are the three concepts that you need to understand in order to have a good understanding how a blockchain works. Okay? What is hashing? Yeah, let's start with hashing. What is hashing? Have you heard about hashing in the past? Some of you have heard. Some of you who has never heard about hashing in the past. Yeah, hashing is a very simple thing. Of course, it uses computer algorithms, but hashing is about create a fixed length fingerprint of certain input data. I repeat it again. Creating a fixed length, so that the length should be fixed, fingerprint of an input data. Look, so I will use myself as an example. I'm a person, I have a fingerprint, right? My fingerprints here. My fingerprints are unique to myself. There is nobody in this world that has the same fingerprints as me. Your fingerprints are different from anyone else. Your fingerprints are also very different from anybody else. Your fingerprints also. So the thing here, this is very important. Now, knowing the fingerprint of somebody, could you create the data, create the person? So the fingerprints are different, but could you, based on the fingerprints, create the person? Create who the person? You may know who the person is, but could you create the body of the person? Could you create the brain of that person? No. Every person has a fingerprint, but from the fingerprint you cannot know the person exactly. This is the same thing in hashing. So when we have data, we hash the data, we get the fingerprint of the data. But when we have the fingerprint of the data, we cannot get the data. We cannot get it. Every person has a fingerprint, but if we have the fingerprint, we cannot reconstruct the person. We cannot reconstruct it. Is it clear? Is it clear? Now, okay, so we are. So I will give you an example of hashing. So you see the web page I have here? this is a hash creator. So I will be hashing, by the way, this text. No, I have to come. Here, I will be hashing this text. Now, first of all, I have to open this web page. Okay, so this is the web page. And I will put here in the input the data, and I will get the output, which is the hash. Here you have the input encoding, etc. So these are mathematical algorithms we will not get into because they, for the purpose of this class, they do not interest us. So now I will be hashing this data. You can hash everything. So you can put a book inside, and you have the hash. You have the fingerprint, let's say, of that book. I just inserted the data from our slide, and you see, I have the hash here. It's a numerical and with letters, D53, C9, F60, 65, 76, 1B. So it's I think there's 64 letters and numbers, and this is the fingerprint of this thing. So let's say, it starts with D, and I will introduce some changes. I would say the blockchains are. I will write the blockchains are. The blockchains are. So instead of having the blockchain is. You see, it has changed. This is 032, 0F. So you change a bit in the data, and then the fingerprint will change. Very important. Right? So we are working with fingerprints here. And the fingerprints is a chain here. It is a series of numbers and letters. Is it clear what hashing is? Now, how do you use it in blockchain? So you can play by hashing a book, right? You will always receive or get this fixed length fingerprints. Now, just come to the slides. Now, let's focus on transactions. Let's focus on financial transactions supported by a blockchain. First of all, how do we characterize a transaction? In order to characterize a transaction, what do you need? Very good. Nice. So let's say we call it, the transaction is called T. It is going from A to B, right? So going from, what's your name? Huh? Aurelio. Aurelio, and to you. From Aurelio to, you will be transferring some money to David, Aurelio, in the example. So it is virtual. And here you have to specify the amount, which is X. Also, what we can do is, no transfer here, only via blockchain. Nice. And then we have the timestamp, right? We can the timestamp. So when the transaction, so it's money transfer from A to B. It is called, let's say, T1. This is transaction T1. The amount is X1 at timestamp 1, at time 1. And then this will form a block. It is called a block. By the way, in a block, you may have more than one transaction inside. So let's do the example with one single transaction in order to make it a bit easier. So this is the block. This is T1, right? So it is from A to B. So this is the sender, and this is the recipient of the money. This is the amount, X1, and timestamp, let's call it T1. Yeah, small T1. This is the first block. Now, in a blockchain, what do we have? Let's say there is at a certain point in time, we have a second point in time, we have a transaction between C and D with an amount x2 at time t2. We do also the same. So this is T2. So this is this transaction T2, just going from C to T. The amount x2 euro at time T1, but it is called a blockchain. We need somehow we need to connect T1 with T2, right? How do we connect T1 and T2? The idea here is to hash this block, because this is information, right? This is data. We hash block 1. We hash it in order to get a set of letters and numbers according to a certain algorithm. And we put it as a part of the block, which is the hash value of T1. And this way, actually, we are connecting T1 with T2. Now, let's imagine we have now a third transaction between E and F, so 2 persons, with amount x3 and a time 3. We can create a third block. It is T3 from E to F, then x3, T3, and then now, what is the hash value? We will be hashing T2 where the hash value of T1 is inside, right? So we will be hashing all of this with the, of course, containing the hash value of T1, and this is then the hash value of T2. So actually, every time we have a block, we should hash it. So we get out of this the hash value, T1, that we put it here. We put it in the second block. So this is block 1, this is block 2, and this is block 3. And then we have it inside, we hash everything. This will get the hash value of T2, that we put it inside block 3, and it goes like this. Okay, here, yeah, this is also the hash value. Now imagine that somebody, imagine that you have and this is not actually unrealistic, that you have 10,000 blocks in the blockchain, and then somebody would like to change one of the transactions here. Changes T2. Changes, let's say, the amount. What about the hash value of T2? Let's say instead of x2 here, let's say x2 is equal to 100 euro. Somebody change it to 150 euro change. What will happen? Exactly. So if we change this one from 100, so x2, it is changed, let's say from it is originally equal to 100, now somebody changes to 150. So the hash value of T2, when hashing this, and hash value of T2 is important in order to get block 3, because we have hash value of T2 here. So here it changes, it comes into 3. Hash value of T2 is part of the block 3. and the hash value here would change, and then all the hash values that would be coming afterwards, they will be changing, right? And you may do this in one computer, but we know that a blockchain is distributed. So if you do it on one computer, you have to do it on all the computers that have the ledger on them. So, and there will be, of course, discrepancies between what has been changing and what is in the network, what is on the computers of others, and then you will see that there is a problem, right? So there is somebody that did some bad actions in order to change some of the transactions. And therefore we are talking about, more or less, in your community, right? Yeah, there is another to talk about it, but here you can see any change will change everything afterwards, and this has to be, actually have to change all, and this is problematic. Is it clear? Is it clear how it works? So the very essential idea here is the hash, right? Please. Exactly. Exactly. So by having this value here, when you hash this and having it here, so you are connecting all the blocks together. Right? So if someone changes one of the blocks, it will have an influence on all the successive blocks. Yeah. Yeah, then there's a problem. Then you can discover it. Then the ledger. Yeah, there is actually somebody that tried to do some bad actions, and then you will see. Let's say it is a network with millions of people, and there's one that is different. So there has been some change, and then it will not be taken into account, right? So obviously it is wrong data. It's not the majority vote, but here is you have 2 millions of people having the same data, and only one saying, yes, it's like all people argue that it is your house, and somebody else coming and saying, this is my house. Yes, that's what he's saying. Yeah, what? Okay? Good. Another thing which is very important is the topic of trust. Let's say what's her name? Mika. Say, money to Javan. But of course, in order to transfer your money, you should be the only one who have access to your account, to a bank account. And also you are the only one that has perhaps the password in order to get into your bank account. And only the one also that can signing or approving that transaction can go from you to Javan. And in order to ensure this, in order to ensure that you are the one that has access to your account, and then you are the one that is signing, you need a private key. You need a password, some private information that enables you, only you, in order to get to your account and do a certain transaction. But there is also another aspect that is important, which is the public key. The others should verify that it is really Mikhail that made the transaction and then made the transfer to Giovanni. Because we have to know, everyone else in the blockchain has to know that it's you actually that did the transaction. It's like, it's your account number. Argue, so your account number is a public information, actually. It is the account of Mikhail. And we know that Mikhail, actually, we can also verify and approve that Mikhail has done, not approving, right? Actually, it is, we can verify and check that it is you that has done the transaction. You see, these are the kind of things in order to achieve trust. So we are used to them. This is also part of cryptography. So here, Mikhail making some transfer to, transfer of money to Giovanna. And here, we know that it is you. And all of the people, let's say, the network, in the network, can check that it is you. Because this is your account number, and we know your account number. It's like, yeah, you know, the regular mail, this mailbox that you have, the physical mailbox. Mikhail, this is your private key. But everyone can access, yeah, when putting the letters. So I can put a letter in your mailbox. Yeah, Giovanna can put a letter in your regular mailbox. But you are the only one that can extract all the documents put in your mailbox. So this is the difference between private key and public key. And we should have them because there must be an authentication that this transaction is done by person A to person B. Good. And the third thing, it is the proof of work. And this is a very essential in the blockchain, a very important aspect. The question is, who will be adding the next block? Who will be adding the next block? So this block, let's say we have a block 4, T4 from J to H, X4, T4, and we would like to create block 4. Who will be adding this T4 into the blockchain? So it's from J to H, X4, T4, and hash value of block 3. Block 3, better here, block 3. Okay, so better it's the hash value of the whole block. Block 1, so the entire block. Block 2. Okay, who will be added? So think of the fact that it is easy to add a block. It's very easy, and everybody can do it. This is, by the way, incompatible with the immutability property because, yeah, you can delete some blocks and then you can, add this block, add many blocks one after the other, and it is easy, and the blocks can be changed very quickly. So the process of adding a block is made difficult. And it is made related with some energy consumption. And what is done here, it is called the proof of work mechanism. It is in the system there will be a mathematical puzzle that will be published. What does it mean, a mathematical puzzle here? It is like we get hash or hashing block 4 plus a number, we call it nonce. We should have a hashing value. Let's say, as an example, it could be different. hashing value that starts, let's say, with 2 zeros. So this is a mathematical process that will be published in the blockchain to add block 4. So we get block 4. We should find a nonce, a variable here, some number, that when hashing everything, we get a hashing value that starts with 4 zeros. And then you will have the network starting to work with brute force. What does it mean, brute force? They will get numbers, different numbers inside, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the computer will do a lot of calculations, and every time we'll hash that value, and we'll get a certain hashing value, and then see whether that value begins with 4 zeros or not. If not, going to the next number. If not, going to the next number. If not, going to the next number. Until somebody in the network finds a nonce, it should be a number that when you put inside here, you get a value, hashing value, that begins with 4 zeros. What does it mean, brute force? Because you don't have any optimization algorithm that enables you to find that number very quickly. The only thing that you have is that you start the number with 1, 2, 3. We are making a lot of trials until you get the hashing value that we are looking for. And this process, by the way, can take in certain blockchains about 10 minutes. 10 minutes, many computers worldwide working on a mathematical puzzle that nobody needs, actually, consuming a lot of energy in order to solve it. And one, let's put this on the side, but it is needed for the blockchain, because if we are making it so easy to add a block, then anybody can add a block. You can perhaps, if you change a block, you can change also very quickly the other blocks. Making it so difficult to add a block, this will improve the security in the blockchain. And this is a consensus mechanism. A consensus mechanism means that who will be the one that we agree upon that will at the end add the block. And this process is slow. It's not very quick. Right? And it is very difficult, actually, introducing this to change the history in the blockchain. Let's say you have 100,000 blocks, and you need 10 minutes for every block to be added. If you would like to change all of these blocks, you can imagine how much energy is required, how much computing power is needed in order to change that block. So this mathematical code is designed by intention in order to make it difficult to add another block in the blockchain. Okay. And by the way, these are the essential ideas. Of course, there are a lot of details, but these are essential ideas how the blockchain works. Okay. Yes? Yeah. It depends on the hash value of the block. So, because you have the hash value of block 1 as part of block 2. So here you put the hash value of all of this inside the next block. It means that when I change something here, let's say the hash value of block 1 will change, and this will change, and this then will be changing, and then all the and then we know that has been that made some changes, and perhaps he or she is not allowed to do that. We know it, so we can compare. Let's say, the hash values of all of the existing blocks in the distributed system, and we see that one has changed. So the question is why it has changed. So somebody with bad intentions has changed it. Yeah, the only thing is that the mechanism of voting also somehow inside. So if, and this is one of the vulnerabilities of blockchain, if you have extremely high computing power, yeah, you can be the one that dominates that blockchain. So the blockchain gets actually its essential feature from the fact that it is a distributed system that more or less the computing power it has. But if somebody, let's say a government, puts a lot of investments in order to have a supercomputing power, yeah, then they may have influence on blockchains. Does it make sense? Is it clear? Any question on this? Yes, please.
Yeah, regarding proprietary or private blockchain communication. Because like at one point, the blockchain transaction system is that it's decentralized for reasons we just did. How is it useful to have a blockchain system? So I can like explain.
Yeah, very good. So, with respect to perhaps you may in a closed permission blockchain, yeah, this proof of work that is using a lot of computing power may not be required. Right? Yeah, so yeah, there has been, by the way, many examples in the past. The technology is working. Blockchain as technology is working. For example, yeah, I'm anticipating here a bit. Yeah, the trade lens blockchain. It is a cooperation between Maersk and IBM. So Maersk, which is a logistics company, very known company, and plus IBM. And they did it in order to coordinate logistics. So you can put on it all the data required, shipping data, bill of ladings, data with respect to exporters, to importers, all the data required in logistics, which is a huge amount of data that is required. And instead of having these paper documents, which could be very vulnerable, right? They could be changed, they could be lost, etc. They thought about having trade lens blockchain, which from a technological point of view, it worked, right? By the way, blockchain, one of the biggest issues of blockchain is not the technology. It is about governance and organization. So, a blockchain by definition, it means that you put the data required or the data in the ledger that are distributed in all computers of the participants in the blockchain. What does it mean? It means that, say, there are two competitors participating in the blockchain. Your data will be with your competitor, and your competitor's data will be with you. Something that many companies say no in front of the blockchain. Why should I have, what is the guarantee that you do not do anything with the data, my data, that is placed on your computer, right? And this is one of the biggest issues. So there's a lot of thinking about how to improve these governance issues in order to make a blockchain really working in practice. Did I answer your question? Or do you have any other comments on that? Yeah. So you think it makes sense in certain areas. So yeah, like this one, which was a good intention. But there are some areas, in the way, for example, when you would like to get real-time information information. So the blockchain can be the storage of that real-time information that can be retrieved. Or, for example, sometimes there are disputes between couriers and shippers. Who's the courier? The courier is the company that is making the logistics. The ship is one that would like to send a shipment, right? And let's say the courier sends a truck, and the truck waits for 3 hours or 4 hours until it has been loaded. And the courier company claims that the truck, of course, has been waiting for nothing and would like to get a penalty, fees for all the waiting time. The shipper would say, no, perhaps. Yeah, the truck was not waiting. Yeah. Is there any proof of that? So if we have, let's say, technology that, of course, that is ensuring immutability, but also that is ensuring that the data is correct, that the data is true. For example, be some IoT sensors or RFID or whatever that shows that the data has been captured the moment where the truck reached the company. So I think this could be a good way to prove this kind of disputes that the courier has to get some fees because the waiting time that was just waste, right? So for this kind of things, blockchain play a very big or a very important role, right? See? For other cases, by the way, and this is what I remarked, a good database would do the job. So why having a Ferrari just to be in the city and driving at 10 kilometers per hour or kilometers per hour, right? So a small database would do the work. But still people, it was like a hype at a certain point in time. Everyone is thinking in terms of blockchain, and I tell you, it does not make sense in all of the cases. There should be specific cases where we need all the properties of blockchain, because you see also that in some cases the costs are high. Good. Any further comment or question? Okay. So here are some distinctive properties. So it's decentralized. What does it mean it is decentralized? Decentralized, it means who is the control authority? Who is controlling the blockchain? Normally, it should be decentralized in the sense that, okay, for money transactions, the bank is controlling all the transactions. In a blockchain, normally there is no centralized control. It is decentralized. The data is distributed. So the decentralization, it is a matter of control. Nobody has the control. Nobody has the full authority on the blockchain. And it is distributed. It means that the data is distributed among the computers of the participants that are part of the blockchain. The transactions in the ledger are validated. They are validated because we have the private and public keys. They are validated when they are also incorporated into the blockchain with the proof of work, the consensus mechanism. Every user has a unique digital key. Otherwise, it will be messy, of course. The information recorded is immutable. I told you before, you may change with one computer, but if you would like to change all the data, the blockchains, all the blocks, 100,000 blocks, with 2 million users, so this would be a massive computing exercise that perhaps nobody is able to achieve. So, and therefore the information recorded is immutable. But one thing which is very important, and this is something that many of my students, they may overlook, is the fact that if you put information inside the blockchain mechanism, in order to see, or in order to verify whether the data is true or not. If, let's say, sometimes, it could be used, for example, in food projects. We would like to put in the, we put in the blockchain that tuna fish, for example, has been fished with sustainable practices. And then the company that is doing the fish, that it has been done in an area that is renewable, sustainable fishing practices, etc. But who is verifying this? This is a concrete supply chain problem, right? Who is verifying it? Nobody. But this is very important. If at a certain point in time it is discovered that the company is doing unsustainable fishing practices, and the company says, no, it is not, it was in the past, we have done everything okay, but not on this period of time, they can go to the blockchain and read the data that has been inserted by the company. And they will see that this data inserted by the company, it was about putting sustainable fishing practices. Actually, they are not doing so. And therefore, we can say that that company has, did a bad action, right? That they are responsible for that. But there is no mechanism, actually, to know whether, okay, for finance, this is different, but in this type of applications, the company is doing sustainable fishing practices. We don't know. We don't know. And the ledger is governed by programming logic. So the programming logic that we talked about. So it is specified in advance. So here you have a blockchain. It is an example. So it is, in the farm industry or the food industry, this is important. Poultry industry. So for example, you have a firm, a farm that is creating or sending poultry products to a processor. So this is the ship form to the processor. This is what is received at the processor, the output at the processor. So there are different blocks that are created every time. This distributor, I'm sorry. The distributor, not the processor. So blocks that are created along the way in order to ensure that the data is there. It is immutable. And of course, we need, if it is possible, and some supply chains try to do it, there is a mechanism that ensures the truth of the data, right? That the data is true. Yes, please.
This is immutable. There's no or factory rewards inside the.
So they are using the technology. So it is immutable inside the network. Inside the network, it means that. Of course, you can have a proof of work that is small, but not too sophisticated. Like here, we need a lot of computing power. And you are right here, as we may think about what is the real advantage of the blockchain. Perhaps a database will do also the work. But the immutability could suffer. Absolutely. If we have the proof of work, which is very easy, it could suffer. But still, if it comes out at a certain moment that somebody has changed something in the blockchain, this could be bad for the reputation of that organization. It will be kicked out perhaps from the supply chains. It can risk also its own reputation, and the brand will get massive problems. Okay? So you are right, but still, it is risky. Potential advantages. Asset tracking. The example of the disputes I told you. We can track the asset very well. So the kind of the truck example with or the courier dispute with the shipper. So visibility across and down into multiple tiers of the supply chain. So this is one of the most important advantages. So to have visibility, so we can retrieve all the blocks and see what happened inside the blocks. Accountability, who is responsible for what? When you put data inside the blockchain, so you should be accountable for it. You are responsible for it. So if it comes out afterwards that the company, as I told you in the case of the fishing, is doing unsustainable fishing practices, and then there is a mismatch between what they are putting in the blockchain, what they are declaring more or less, and what they are doing. Process conformance, whether we are doing things according to what has been prescribed. And yeah, could be some improved collaboration across the supply chain because there is more trust because of all the mechanisms that are embedded in the blockchain. But yeah, here, yeah, the examples I told you about the Maersk and IBM example, but also DHL has used it in the pharma industry against the counterfeiting of drugs. Yeah, it could be also important, but more importantly, for example, could be used, let's say, in cases where, for example, refrigeration of medicine is important. So we are tracking by means of a blockchain all the temperatures that certain vaccines have been in during the journey until they reach hospitals or until they reach doctors. Of course, there may be some changes, but still the risks are much bigger. And when we have just a database, right? Database is perhaps very much easier um, to attack, right? So yeah, we can have a traceability of all the temperatures. We can have better traceability of the medicine and the authentication of medicine and important data of medicine, right? With respect to blockchain problems, we have a problem of scalability. What do you think? Why is it problematic to scale a blockchain? To scale up? Okay, in permissioned blockchains, we have talked about the problem that some companies may be against putting their data on others. So this, for example, TradeLens, this joint blockchain between IBM and Maersk, is not existing anymore. It was a very good idea. It was a very good project. Technologically worked very well, but it could not scale up because organizations that this case and people, of course, necessarily they did not want to come into that blockchain project because of trust issues, having data in someone else's computer. But also there is another problem, which is technologically driven, why it is very difficult to scale up.
And right block with miners, it's not
So yeah, very good. Thank you very much. So the miners, I did not use that word. The miners are the computers that are solving the mathematical puzzle. So they are called miners in the jargon of the blockchain. And as we said before, you need 10 minutes in order to add a block. So in order for that block to be added, you need 10 minutes, so it is slow. When you do now an instantaneous bonifico transfer, how long? It's almost, you send the miners almost there. In blockchain, it will needs more time, right? So, and this slower process will lead to the fact that you cannot scale it up, easily as other, other processes. For example, a normal bank transfer. You'd like to say another? You'd like to say another thing? Cost and energy usage. Yeah, we have a lot of miners that are working on the mathematical puzzle, so it needs a lot of energy. By the way, Bitcoin, just emerged out of this energy consumption that is used by miners in order to add blocks, or to validate and add blocks. So this is, they could be that, this is more or less the reward, the compensation for the computing power and the energy used in order to add the blocks. But this is another topic. We're not going to go into Bitcoins here. The lack of regulation. What about transfers? Across borders. With blockchain. So still regulation, etc. They are not out there. Data quality. I told you before. Data quality. If you put something wrong, it will stay wrong. This is all what the blockchain can do for you. The truth of the data. This is something you have to care about in different manner. And then a lack of knowledge. So general And I tell you, this is the lack of knowledge that led to many organizations using blockchains perhaps for projects that would need just a very simple database. So using a Ferrari car just for driving 10 kilometers per hour, it doesn't make sense. Please.
Like when you think of the space, where instead of a table, you have a pointer to another object, which is a technology from like the 70s.
Absolutely, yeah.
Like it's a visual analysis for. So blockchain means nothing if you don't add the decentralized after it.
Yeah, you are right. Yeah, some years ago when I'm defining blockchain, I'm saying but I'm not saying this because some people they feel offended because blockchain. But it's storage. Yeah, it's storage of information. But the storage of information in a very particular way. Yeah. Good. Yeah. Any further comment or question? Okay. Not. Yeah, what about having, we don't have break, what about having a short discussion of the paper that I distribute or that I gave you? Good. Yeah, the papers, by the way, they're important for the exam. So we have discussed them, I think, at a very good level of detail. Yeah, with respect to this paper, which is short, I think short and precise. Could someone make a short summary of this nice article? It was like half. I was not sure, but yeah, you were the first.
It's a trend that was growing it's a thing that is the new activation and the additions to this trend. So one thing is quite comments that the companies being able to produce the best way and fast way on the macro level. Recommendations for small towns. People just like offering custom products, small size scale, supply chain to this production trend. So the offer the fastest option for the business for high products. So
On a mass scale, sure. On a mass scale, yes, please.
and moreover, it is also change of the perspective of requirement of equipment or other machinery. Because I think that this book chain and focus on but we doesn't have to use those. We can perform those by another example is about other firm that produce components of which are thanks to this new model. So, working parallel with the agile model and also with the lead model. Those are more about cost efficiency and time efficiency. But then, this is about high-speed bespoke is more about combining this and
Good. There's no end. Thank you. Thank you. Would somebody like to say?
this fast working for
Very good. So this is an aspect related to market intelligence. What you would like to say something? Exactly. Okay, very good. Yeah. Then yes, and not many contributions. So you and yeah, yeah. And then
I would say like it's also in a way, provide and
yeah. Actually, Fisher's yeah, thank you. Fisher's model was more focused on make to stock actually, and the high-speed bespoke supply chain is rather focused on make to order. Right? And this is the last contribution because we have to. Exactly. Very good. Very good. So I have to stop the discussion here because yeah, yeah, we have to move forward. By the way, I prepared some slides as an exception for this article just to summarize everything. Here you have the explanation of the things with respect to the limitations of blockchain. So the high-speed bespoke supply chain is, yeah, its characteristics are quickness and product customization, manufacturing and fulfillment of rarely ordered products. Yeah, we should say very important that the high-speed bespoke supply chain is based on 3D printing. Okay? So this is why it is short, and also it does what is called market intelligence. What does it mean, market intelligence? It means that you can get some input, some information from the customers about the trends, about what are the kind of customizations that customers would like to have, and you can translate that trend into the mass-produced products, right? So, for example, if you see certain designs are ordered by people that are ordering my Adidas product, and then you see a certain trend, you may translate that trend into the mass production and then put it for all customers, because you are here spotting a trend, right? And this is what is called market intelligence. So market intelligence should be very clear here. Then Fisher's framework is here, and it has been also explained. It is rather lean and responsive, focused on make-to-order, high-speed, bespoke supply chain. They are actually adding a new type of supply chain strategies which are focused on the make to order. Here we have the example of the My Adidas factory. It's actually, you should not think about the fact that all of the shoe is done, is printed, right? It's not printed, so it is only the bottom part of the shoe that is printed. The other stuff is still not printed. And they have the so-called capabilities of the speed factory. And after 6 weeks, I think customers can get their products. Although My Adidas is experiencing some issues. Some of them has been discontinued, by the way. Then we have here the Mercedes-Benz example. So, look, it was, we talked about, in the paper, they talked about plastic parts, right? So plastic parts, you can print them without any issue. And the idea is, some old models, let's say, of trucks, need spare parts that you don't have on inventory, don't have them on stock. And keeping them on stock, it could be very costly. And also keeping the capabilities for making them, it could be very costly, especially if you have dedicated injection molding machines to make these kind of parts. You know, injection molding machines, they are very expensive. You need molds also that are very expensive. And therefore, since you are needing these spare parts from time to time, what you should do, and this is what Mercedes did, we don't put them on stock, right? We don't put them on stock. What we do is that whenever there is a need, an order for that product, we will be making them very quickly by means of 3D printing. By the way, the things that are going on with 3D printing are amazing. I know of projects, for example, that are still also going to implementation of printing parts for aircrafts. So think about the fact that you have a Lufthansa machine that is in Japan, in Tokyo, for example, and something has been broken, and it cannot fly back to Frankfurt. What will happen? It will be on ground for a long time, waiting for repair services, right? Why? Because Lufthansa has to fly the component with the next machine to Tokyo. Then there should be some repair, and then it comes back. And this can take a lot of time. The thing here, what we can do, of course, is that we can very quickly print the part, as long as it is reliable enough. This is one of the big issues in the aircraft industry. And then it can be inserted, or it can be, the aircraft can be repaired, and then it is functional again. So this is, the kind of uses we have here. Okay, here for printing spare parts for old, discontinued trucks at Mercedes. By the way, in the meantime, you can even print houses. And then really, you can see some videos. They're really amazing. You have a printer that is making the house layer by layer. You're putting concrete layer by layer, and you see that it is growing up. You can also print food. I really don't know how it works. I have never tried food that is printed, but I know that, technology is also evolving in that area. So you can print food. Don't ask me too much. I have just heard about it. But perhaps it's better to get the fresh food instead of the printed. And then we have the example of metal. Metal is also an interesting example. It has been actually done in order to, actually the 3D printers are with the kids. They buy them, perhaps 200, 300 euros, and then here they can print the toys that they design themselves, or they can also print toys that have been discontinued, so very, very old ones. Or even perhaps they can print new ones and see what are the new toys kids are interested in, and this will give them market intelligence in order to feed information to the morphology area, where they can then use that information for the mass market. Please.
But perhaps they will not just make higher they call it final. Yeah, to
With respect to the printer, you mean? Yeah, you can use a general purpose machine.
I mean, not really the 3D model.
No, it's difficult. Yeah, this is, by the way, you can do, of course, yeah. And by the way, the applications of 3D printing, they are sometimes, I would say, crazy. By the way, if we change production from the machines that we know to 3D printed, 3D printing to generative or additive manufacturing in the future, yeah, it will be more or less, yeah, designs. Yeah, protection of designs will not be the problem. It will be a problem of the protection of the software programs that you use in order to print this kind of physical products. And the kind of printing that you can do is amazing. Yeah, you can even print things that are functional, that they're turning inside, their mechanism are functional inside. So it's amazing. And yeah, I think supply chains will change because if you can print products that are functional, and that they are assembled, let's say, by definition, by construction, so they don't need suppliers, you don't need long supply chains, so supply chains have to be rethought completely. Therefore, I put also 3D manufacturing here, looking forward topics, because if it will be on a mass scale, what we will have, so far we are not that far, so we are not on the mass scale, but if we can achieve that mass scale, our supply chains will change, definitely. So far, we cannot print a computer, perhaps only parts of the computer, because you cannot print chips, etc. But for a bunch of other products, things could be printed, and many companies have to think about this very seriously, right? Very, very seriously. So you're right here. Companies have to be careful, have to, let's say, track this very carefully. Good. And then, yeah, there are also barriers to adoption. Yeah, what kind of adoption barriers may encounter the high-speed bespoke supply chains? So there are many barriers here. Companies should be sure they understand here and how they want to benefit from high-speed bespoke strategy. So look, Mattel was giving, let's say, new designs to be printed, or also old designs. Then Adidas was rather providing the possibility for perhaps athletes and sophisticated users, let's say, to print their shoes. Then we had Mercedes-Benz rather for spare parts. So there are very different ways, right, of doing it. So we have to be careful about whether and how we would like to use it. Then additional investment. Yeah, we need, of course, printers. We need also to learn about it. Perhaps the printers themselves, they are not too expensive, but learning how to use them in order to have products that are functional, this could be really a challenge. 3D printers may be supplemented with with other highly flexible and automated manufacturing equipment. For example, Daimler is offering 3D printed plastic spare parts, but not, say, replacement of gearboxes or engines. So you can print this kind of plastic parts, but gearboxes, it will be definitely not possible. And distribution, by the way, this is important. For this kind of product, the distribution is not the mass scale distribution that we know, through distribution centers and then sending big trucks full of products. Here, what we are doing, or companies, what they are doing here, it is very, very close and very, very to the last mile delivery of companies like Amazon Prime. So it rather resembles Amazon Prime than it resembles, let's say, the distribution of a big household appliance producing company. Okay. Yes, please. You can print? Yes? Yes. Absolutely, absolutely. So the technology is evolving, so you can print many, many other things. So it was, the article was in 2017, it was written in 2017. We are not, let's say, so far, these high-speed bespoke supply chains, they are not everywhere. But still, of course, the technology is improving and a lot of progress is done. And what has been predicted or what the authors are warning could be a reality in the future. So, but I think it's very, very important to consider this or to end more or less supply chain innovation course with this perspective. I think it's could be very important in the future, especially supply chains with choice. So supply chains now, they are distributed globally, but with this, supply chains will get shorter, and then another problem is hacking, right? So it's not about hacking a product, how it is constructed, it is about hacking the software that enables you to print the product. And once you get that software, you can get the product, basically. So it is about virtualizing or digitalizing physical products. Good, we are done here. Do you need 5 minutes of breathing? And then we will do, or we can continue directly with the exam preparation as you want. Who needs 5 minutes just to breathe and to get? Only one. So yeah, the blockchain doesn't work here. So it's too few miners. Okay, so let's go to the exam preparation. Before that, do you have any question about the exam, about the topics, about what we have done? General questions before. Yeah, I know. During this period, my students are generally very tired. We started, of course, learning for the exams, right? So it's a tiring period, but yeah, we try to manage. Huh? Good. I have prepared also some slides here. The slides, I will upload them after today's lecture. So I think you are very, very well prepared for the exam, by the way. You are very prepared. Okay, there is still one lecture next week. During the lecture, as I asked many questions. And no problems of asking the same questions I asked in the class. Because these are the important questions that we have dealt with. So there may be, of course, questions that I did not ask, but related to the topics. But yeah, I remember we have done many exercises for the supply chain analytics, for the supply chain technologies. Also, I have asked many questions, and I told you every now and then, I told you that it could be an exam question. Right? So I have prepared here, okay, some relevant information about the exam, just to tell you about context. First of all, it will be strived for to publish the results of the assignment before the first call of the exam. I know this is something that most of my students like. They would like to know more or less what they got in the assignment, so that they can start making calculations. How much do I need to pass, and how much do I need in order to get a good grade? Yeah, man. I think, okay, I try to do this so that you get the grades before the exam. According to the information I have to the system. So the exam date is 18th of June. So it starts at 8, but we will start at 9, okay? We'll start at 9. Yeah, there will be also a wee bit communication to all students that will start at 9, okay? And the room is 2005. This is what I got from the system. But please look continuously into the system because there may be changes. Also, I do not change the rooms. I do not change the dates. I get the dates from my administration. I get also this kind of information regarding the room, etc., from the administration. I do not have any control of it. Okay, so very important that you also look at that. On that information. So 2 or 1 day before, please have a look also in the system. Yeah, the exam duration will be 60 minutes. So after 60 minutes, you are done. The exam contains 4 to 6 questions because I do not prepare the exam, and generally I do not do it before the exam preparation, not be biased. Yeah, think of the fact that I already prepared the exam. I will give you a lot of hints about the exam, right? So I will not do. I will do it next week, perhaps. Okay. So after we do this exam preparation, the exam may contain 4 to 6 questions. So this is about my experience in the past, and of course, each question can have sub questions inside, and each question can be graded from 5 to 8 points. So if we have 4 questions, perhaps we may have questions with 8 points. In general, I provide exams with 32 points. Good news. 32 points. It means that you can reach 32 points. At the end, the grade will be on 30, but you still have 2 bonuses. So, yeah, in order to make, for those who can do everything correct, we got 32, and then this will be allowed in excellence, right? Criterion. The questions are open, so there will be no multiple choice questions. And please bring your laptops with you during the exam to answer the questions in MS Forms. So there will be an MS Forms in which you will be writing. So, and then you will be submitting your exam by MS Teams. MS Teams, what I'm saying, via the MS Forms. Yeah, so it's easy blackout for seconds. MS Forms. Then all the materials distributed in class are relevant for the exam. Also the articles, okay? So I may ask questions about the article of today or the other 2 articles. Yeah, here are some examples of questions. This is one exam I had in the past. Yeah, what is DMI? Explain which business process management principle supports the DMI. I will upload everything. So I did not upload it, of course, in order to have today's session better as a discussion. Yeah, what is VMI? Yeah, how does it work? Very good. And based on that, has the information only, it is not a full answer. Right? Going to be very, very careful here. There's no ordering that is created here. So ordering, it means the customer will place an order with the supplier, but there will be no ordering. So it will be based on the customer data, the inventory data. There will be a shipment that is done by the supplier to the customer in order to replenish the stocks at the customer site. It could be a retailer, manufacturer, right? So the manufacturer is shipping for replenishment. Explain the business process management that is behind it. Yeah, it is a bit of detail here. It was some time ago, perhaps 6 or 7 weeks ago, right? What is the business principle that is used in BMI concept? Nobody? Small impact? No. No, we have not talked about visibility. Yeah. It is put the work on the one that has incentive to do it. This is one of the principles. So push the work on the act that has incentive to do it. So we have talked in that case on vendor measurability and scheme-based trading. So this was principle 3 out of 4 principles that we have done in business process management, especially for the generation of radically innovative ideas for business process innovation. Yeah, the second question is about, innovative ideas can be created using the principles of combination and analogy. Explain what combination and analogy are. What is combination? You see, there are many sub-questions inside the question.
When you create technology,
Very good. By combining technologies, we have seen it also in business models. You can combine business model patterns in order to generate a new business model for the company. You should have done this in the workshop and the assignment. You want to say more? Yeah, what is analogy? It was half a second before. It is actually you get inspired from an area where we have a solution to the problem. We translate or we transfer that solution from one area to an area where we are looking for a solution to a problem. Okay? Then why is it worthwhile to combine blockchain and RFID or sensor technologies? Yeah, we have done it just now, so you should be able to. Why is it advantageous, perhaps, to combine sensor technologies or RFID with blockchain?
I mean, RFID is the blockchain. Basically, where use create the product and also and get down.
Very good. So here, RFID can track the specific product. The sensor technology can track pressures, temperatures, different parameters in the environment of the product. Combining it with technology like blockchain, we are actually automating the or the insertion of this data in the blockchain. So if there is somebody doing manually insertion, the of the information to the blockchain, this data will be for sure wrong. Having it coming from RFID, from sensor technology, this document of the data. If you had an RFID tracking when the truck arrived at the would be fine. So completely integrating with blockchain. If people are doing doubting about the validity, please. Exactly. Yeah. Absolutely. Very good. Nice. Yeah. So you see, this is a simple question. Also. Yeah. Here you have the answer. Okay. I will upload everything, also with the answers. Explain the difference between incremental and radical innovation in the supply chain, and explain the reason why you consider them radical and incremental. So here, I would like that you provide a difference between what is incremental and what is radical innovation, and then to provide examples for incremental and radical innovations in the supply chain. Changing a little bit of what? By the way, the answer is in part right, but there is something that is missing. For example, if I do not get it, there will be some points going away. What is missing here? Yeah, there are some steps of improvement of what? Performance. Very important. So this is there is a step or an incremental small steps improvement in the performance. And radical is there is a big step of improvement in the performance. Very good. So I'm referring actually to this picture. So performance is improving. And now some examples. Yes. Okay, very good. Yeah. Here we're talking about supply chain radical innovation. So it's the supply chain. So RFID, is it a radical supply chain innovation? Yeah, I think here what could be radical is a complete change in the supply chain and how it works. So, for example, think about what is more radical, RFID or the shipping and shopping supply chain by Amazon, right? Exactly. So RFID, of course, and here AI, let's say AI is, it's a, it will be, of course. I need some argumentation about perhaps the performance, how the structure changes, some arguments that are really, it could be one single argument, but I see that you understood what is the difference. For example, incremental SCI innovation, reduction of fuel consumption and transportation. So you can have a better rerouting optimization, or you have a better engine to have less consumption and transportation. But radical supply chain innovation deals directly to the customer supply chain. This is a completely new way of doing the supply chain of the computer industry. The high-speed bespoke supply chain is a completely different way of doing the supply chain. So it is more than one single technology, right? So there is a complete change, structural change, configurational change in the supply chain. Now, what is lead user innovation? How is it possible to identify lead user innovation or lead users or lead user innovation. How do you want? And give an example of supply chain lead user innovation. Yes. I would like here just to make a comment. It is sometimes not an improvement. Sometimes it is even a completely different product that has not existed before. Think about the mountain bike. So the mountain bike was not existing before, right? So it was a new product completely invented by lead users. Think about kite surfing, let's say. Kite surfing, it was not possible before. Lead users came with these new innovations. Right? So it is a new, it's not an improvement, it's not an incremental, right? Yeah.
As retail consumers about additions that move to innovation. And this can identify more rather than innovation work in products.
Yeah, we're asking many customers. Yeah, I did not get it very well.
So that they consumer and also we identify and what they want to serve.
Yeah, no. This is, by the way, this is the space of also making mistakes. Discussing. Yeah, no problem.
That's as the user have focused on, for example, on really understood by others at this moment. And other customers instead are focused on the everyday.
This is right. So it is not that it is not understood. The need is not understood. The need has not manifested yet in the other users or the normal users, let's say. Okay, so it is more or less a latent need. So it's like imagine before the mountain bike, there was no mountain bike, but when it came on the market, everyone said, "Yeah, Many people said, I need a mountain bike because it was latent, right? It was latent. So, lead user innovation. So, lead users have two properties. So, they are ahead of a market trend. So, they spot the market trend. They have visionary, let's say, needs. The market will follow afterwards. And they have an incentive for doing it, for making the product. So they are ahead of certain market trend, and they have an incentive for doing it because they will draw benefits from the product once they make it. Right? So this is the first sub-question, how to answer it. The second is how do we spot, how do we identify lead users? Lead users are identified through the pyramiding process. Remember, we start at the bottom of the pyramid. Sorry? Yes, it's pyramiding, yes. So it is how we start at the bottom with perhaps just experts, and every time we're asking. Every time we continue going up, we continue finding people with more expertise. Exactly. And we reach the lead users. So it is contrary to what is called snowballing, because snowballing, you are just looking for somebody with similar level of expertise. And in the supply chain, it has been implemented, like, let's say, retailers, for example, retailers, they are the ones that are most interested in having systems for inventory management that are very sophisticated, right? So they could be the lead users for inventory management software, for inventory management algorithms, ideas, and then companies, software developers, for example, they can get inspired from these lead users in order to make systems that are very sophisticated, and then more sophisticated than the ones that are existing, and can be used by a wide range of organizations like manufacturers, etc. So this is one of the examples where lead user innovation has been implemented. Now, define what a systemic innovation is. Is it possible to say that containers is a systemic innovation? Explain why. What is a systemic innovation? Yes? Yeah, it's trying. Yeah, it's trying. I know until the exam you will get very well. So this is about recall of memory, right? So, yeah, knowledge, somehow you have to be able to recall it. So if you say, I have the knowledge, but you cannot recall it, you don't have it. So you should recall it, right? So it is aspired to recall that knowledge. Very good.
Just to be correct, that knowledge needs to be spread along that process. Okay.
Government, many different stakeholders. Very good. I will give you full points for the question. Yeah, very good. So, yeah, systemic innovation is an innovation that affects many actors, right? And obviously, yeah, here you have an example. Electric mobility, for example, is also systemic innovation, and the container is a systemic innovation because it impacts the shippers, the shipping lines, rail operators, truckers, port authorities, etc. By the way, just for you to be prepared for the exam. So these are more or less the qualitative questions. Perhaps there could be some more quantitative questions, but I will not tell you about using Excel. So you're not expected to use Excel during the 60 minutes exam, but what you are supposed to be able to do is then to make some modeling. And by the way, this is a question from last year's exam. From last year. So I will read very quickly because there is a lot of things to read here. So consider the following transshipment problem with 3 producing nodes, factory 0, 1, and 2, 3 distribution centers, 3, 4, and 5, and 4 markets, 6, 7, 8, and 9. Factories 0, 1, and 2 have capacities equal to 450, 380, and 540 units respectively. Demand quantities in markets 6, 7, and 8, and 9 are respectively 300, 230, 180, and 255. Write down the objective function and identify all constraints of the problem and write them down. And it was a 5-point question. Write down the objective function, it was 1 point, and identify the constraints of the problem and write them down, it was 2 points. Now, important notes, be careful with function and constraints. Any mistake, even minor, will result in the corresponding equation or inequality to be considered incorrect. So if you have plus or minus system, it should be incorrect, okay? Very important. And then for the variables representing quantities, because here I'm giving you some notation conventions in order to get more or less the same results from everyone. Use the notation x, y, j, where I denotes the shipping node and J denotes the receiving node. For example, the quantity shipped from factory 0 to distribution center 5 should be written XO5. Because I'm a very kind person, of course, this would be perhaps enough, but I gave you also this. I gave my students the transshipment network. I also gave them this. But believe me, a lot of students have struggled with this. I don't know why, but we have done an example that is almost equal. So I do not need you to, and I put all of the data. I put all of the data here. So that you have literally this with the question text. And then I need the objective function. And then I need also the constraints. Yeah, what is the objective function? Could somebody try? What is it? Here we have the costs, right? In a logistics network. What we would like to do? Yes, minimization. What is the objective function? Yeah, and how it is written? Yeah, just start a bit here. Sorry? No. There's something that you're yeah, forgetting. Exactly. Plus then x 5 euros times x05 plus 9 x13 614 7 x15, etc. And then, of course, this is the first part, and then plus 10 x36 x3 9 x37, etc. etc. So yeah, it would be a bit cumbersome to write it, but this is possible. It's going, yeah, step by step forward. So this is the step of modeling, by the way. I would say even it is half of this modeling because I'm giving you also the scheme. Because once you have the scheme, you can write the mathematical model without any issue. Okay? Now, with respect to the constraints, what are the types of constraints we have here? Gabriel, before, what are the types of constraints? Very good. Transshipment constraint. Yeah. Very good. Now, give me one capacity constraint. Excellent. Excellent. This is excellent. So you have all what is coming out factory 0 should be less or equal to 450. Now, what do we have on the market side? Let's go to the market side. 300. So we have to satisfy the demand for each market. So everything that is going to 6 should be at the end equal to the demand of that market. And then another equation, series of equations, what we need also is the transshipment, the balancing, right? So let's get with 3. So this is, and then of course we should have the x's, all the x's that are positive integers, right? Because we are talking about goods that we ship. So, and this is the solution. So if you do this, you get 5 points. Without, yeah. And then I have even another one. And it was a bonus point, a bonus exercise here. It was 2 points. It is long. It is long, but the answer you will see. The answer is very short. Can I read, or you would like to read it alone? Okay, a washing machine distributor operates several distribution centers, each shipping machines from different manufacturers to major electronics retailers like MediaWorld and others. Currently, each distribution center places its orders individually with the manufacturer. So every distribution center belonging to the distributor is placing its own orders alone, preventing the distributor from consolidating orders and benefiting from economies of scale. Let's say the distribution center 1 is ordering from Bosch alone, distribution center 2 is ordering from Bosch alone, let's say washing machine, whatever. So actually, it would be nice if there is some consolidation. The individual distributor centers use a management orders are triggered when all this is the order point policy. The stock is decreasing. When we achieve the order point, we are reordering. The stock quantities recorded in the enterprise system, the basic IT system, often do not match the inventory. So the inventory levels that we have really, they are not matching with what we have. As a result, operators must manually verify stock quantities before placing orders with suppliers. So yeah, you can see how cumbersome it is because you don't trust the information that you have in the system. What you should do is that you go every time in order to count and to see what is the number of stocks and the units you have in the warehouse, and then based on that, you would be placing orders with the customers, with your suppliers, sorry, with the manufacturers. As a result, operators must manually verify stock quantities before placing orders. Now, you have been assigned to a supply chain innovation project aimed at addressing these challenges. Propose 2 technologies that could help consolidate orders across the distribution centers and make the replenishment process faster and more accurate. Consider technologies that could, and here I'm giving you details or some hints. Consider technologies that could enhance real-time stock accuracy and improve the efficiency of the replenishment process. Explain how the improved process would work after implementing the technologies you propose. It's very long, I know, to read it, but believe me, I have the answer. It is in three lines. Difficult? No, you should not. Actually, yeah. If you say it's impossible, you're not getting it right. Because what I'm looking for here your analysis, and that you're providing 2 technologies that once you implement them and you provide me why, I'm interested also in your argumentation. Why is problem? Yes. You don't need a unified structure because this will cost a lot to the company. And this is also unified ERP structure is not a technology. So it is like coordinating, or trying to fix an existing technology. Here the question is very clear. Propose 2 technologies that could help consolidate orders across the distribution centers and make the replenishment process faster. Yeah, you are very modest. Yeah, you are very modest. Maybe perhaps you will come up with the right answer. Exactly. Very good. Yeah. What would you? Very good. Great. The second step is about the consolidation and then sending the orders automatically. Last lectures, technology, RPA. RPA can do this consolidation, can verify whether we achieve the Right. Yeah, we get the information from the IoT, from the RFID, then we can consolidate everything. We don't need coordinated structures because this will cost a lot of money. We need different robots that will capture that information, and then a robot that consolidate everything, check everything, and then ship the emails with the orders to different manufacturers. So this is, by the way, the answer. This is my answer that I provided as a reference. Yeah, for example, computer vision or RFID or IoT to track goods in the warehouses with RPA that compares the current stock with the order point, consolidates the orders from different distribution centers and places a consolidated order with the corresponding wash machine manufacturer. Yeah, of course, if sometimes students have provided other arguments, of course. So this was my model answer. But of course, if there are some good argumentation, yeah, I thought that it's really real substance behind it, I accept it, of course. Good. Any question on this? Is it difficult, this one? No, it's not. It's not difficult. So this is 2 points. You get them, yeah, more or less as a present. Yeah, please.
My question is, I didn't understand how can we solve this problem? Because circumstances, every person different times.
Then you can consolidate what you got from different distribution centers. So if you have, let's say, 4 distribution centers and you got only from 2, yeah, then you consolidate these 2. But at least there is an effort for consolidation instead of not doing anything. Even if you get 1, but there is still an effort for consolidation.
There was a question.
Yeah, please, could you, the student who has the question, could you please open the mic and ask the question?
Yes, Professor, thank you. I was just asking that can we use periodic review model instead of reorder continuous monitoring of inventory? Because I thought this was a problem in the question.
Could you please repeat once again the question? I think the volume was so high that I could not really understand. Also, the students in the classroom could not understand the question. Could you repeat it again, please?
Yeah, thank you. I was saying that in the question, there was a problem that they had no visibility on the inventory, not efficient. Can we use periodic review model instead of economic order quantity? Because it provides, continuous monitoring of inventory.
This is a good question. It could be perhaps nice. Yeah, this is a very nice suggestion, by the way, but it is outside the question that we have here, because periodic review policy would be even more sophisticated, because with the periodic review policy, all the distribution centers will send, let's say, every 2 weeks, or they could be coordinated in a way that every 2 weeks they check the current stock, and then the robots can consolidate everything, and then they place an order automatically. Because you are right, when we have reorder point policy, so the different reorder points, they could be at different points in time. And then in order to consolidate, we have to wait a bit until another replenishment order comes. But when we have the periodic review policy, we can coordinate all of the distribution centers, is that the robot, let's say every week or every 2 weeks, they capture the current stock levels, and they will be placing a consolidated order across all the distribution centers. So thank you very much for the suggestion, because it will help a lot this. But it is outside the question, but it is a very nice improvement for this distribution center and for this distribution company. Did you get very well the suggestion? It is very, very good, right? Very encouraging. Good. Any other idea? Any other comment? So if not, yeah, I would like to thank you very much for attention, for being here every Monday at 8:30. I know it is not easy. It was nice to work with you during this semester. Yeah, very nice group. By the way, both guest speakers, when they told me after, I mean, the guest lectures, that this group is really contributing a lot. They were very, very positively impressed by your contributions and your uh, yeah, input during the class. So, and then I confirmed this. Thank you for this, and nice group. And then the big present you can do for me is that all of you write good grades. By the way, I do want only to give good grades, really. Yeah, every professor would like to give only good grades, but of course I just grade what I have on the in the exam. So. And I wish you a lot of success in this exam, of course, especially this exam because it's mine, and of course all of the other exams. Yeah, in this, yeah, I know a very tiring period, but I wish you a lot of success in it. Thank you very much, and see you around. Yeah, thank you, thank you, thank you, thank you very much. Good. Don't forget the 4th of June with my colleague online.